Can you predict the hand movement and legs movement of this toy? Seems very random and unpredictable, right? But predicting weather is much like predicting the hands and legs movement of this toy. It's very chaotic.
About 2 months back, IMD issued a red alert suggesting that it was going to rain heavily within and around city. This red alert prompted a lot of schools and colleges to be shut down for 2 days. Only it turned out to be zero rain and clear skies.
IMD later issued a clarification that this alert, the red alert, was only for outer city and not within the city. But this is not the first time that weather predictions have gone wrong. And there is a science behind it.
To forecast whether how it's going to be, is it rainy, windy, or like that.
Okay, and do you plan your holiday like weekend getaway based on those weather apps?
I have done it, but it has not been the most accurate one.
Okay.
I would say 60-40 kind of ratio.
60-40.
Yes.
Okay, has it ever happened that you saw in the weather app a clear sky and then you went out for weekend getaway and it started to rain?
Yes.
Does
It has happened, yes, many times.
Okay.
Sometimes it's hell, sometimes it's not. But basically, when it's the constant weather, like it's totally summers or winters, then definitely it works. But when there is fluctuation, specifically in rainy season, it's not so much effective.
Okay, so in rainy season it works 50-50.
Yep.
So predictions work 50-50.
Yep.
We have supercomputers that can simulate the universe right from Big Bang to now with pretty high precision and accuracy, but we cannot predict weather for next week. We can predict eclipses for next million years. We know what will happen to moon in million years. We'll know what will happen to earth in million years. But we do not know how our economy will be in coming years. When will next recession come in? Forget about this. We have got CCTV cameras and sensors all across the city, but we cannot predict when will next traffic jam happen at any given road. We humans, we like to have everything under control if possible. That means predicting everything, how it is going to behave. Or in other words, forecasting it. Be it weather, be it economic forecasting, be it how traffic is going to behave or when the traffic jam will happen. We like everything under control. But some things are not as straightforward as it looks. We have always thought of prediction as a linear thing. Means that the cause and effect are directly proportional. A gentle push to a ball will only move the ball that gently. But that is not always the case. Weather prediction is as old as humans themselves. Ancient people with lack of any tools like thermometer or barometer would observe the sky, animal behavior and make a prediction. For instance, if they noticed clouds gathering, they would predict a rain in near future. And this linear way of thinking, of predicting the weather, followed until the 20th century. For a long time, scientists believed that given enough data about atmosphere, like temperature, wind speed, and pressure, predicting the weather should be straightforward. And these models appeared to work over a short time periods. Weather does exhibit some level of predictability. Short-term weather prediction was working fine with intuition, experience, and help of some basic tools like thermometers and barometers. One could easily predict if it is going to rain in a couple of hours or next day. It was the long-term forecast that was pretty difficult. Like, will it rain in next month? Will it rain in next season? Now, this is the tool that was used for weather forecasting. All you need to take is the wind direction and the reading in barometer at sea level. Over here, if I match it from a local location, the reading is A. And what does A say? It says that the weather is settled fine. And the weather looks, well, a little bit cloudy. Weather prediction over large scale and long term was done with historical observations and manual calculations, but its accuracy was a distant dream. A change had to come, and it came in 1950s. This change was from manual calculation to digital calculation. It was led by Princeton University mathematician John von Neumann. He advocated the use of computers to predict the weather.
We computed the trajectory of a shell that took 30 seconds to reach its target. A young woman with a mechanical desk calculator spent 1 or 2 days calculating such a trajectory. The ENIAC computed the trajectory in only 20 seconds, faster than the shell itself traveled.
And his intention was to make weather as a weapon. He wanted it to use against USSR to give North America an upper hand in the Cold War. But till that time, weather prediction was looked as a linear thing. Then, one day in 1961, when Edward Lorenz, while running a weather simulation, Lorenz wanted to recheck a certain portion of his weather model, but instead of starting the program from the beginning, as he didn't want to go through the hum and clattering noise of Royal Magby computer, he started right from the middle. He got the printouts of the earlier simulation and re-entered the data from a midpoint. And here is where it gets interesting. Those numbers were slightly rounded off. Instead of typing all 6 numbers like decimal 506127, he just entered decimal 506. Not his fault, as printouts showed only 3 places after decimal to save the space, although computer's memory kept 6 digits after decimal. Lorenz was well aware of this. He expected his simulation to give him nearly the same result as before. After all, what harm could such a tiny difference make? When he came back later to check on the results, Lorenz was shocked. The new simulation started similarly, but after a while, it went completely in a different direction. The tiny difference that he had entered, just 1,000th part of a number, had grown into massive change in the final outcome. And that's when Lorenz had a huge realization. He figured out that long-term prediction was doomed. Weather systems are incredibly sensitive to even the smallest changes in the starting conditions. Think about it. All sensors giving accurate and high precision data all the time is very difficult. And I'm talking about at least 6 places after decimal to predict the weather for next week. What Lorenz stumbled upon came to be known as butterfly effect. The idea that a tiny change, like a butterfly flapping its wings, could lead to big differences down the road. After seeing this, Lorenz created a set of equations to explain this kind of unpredictable behavior. When he plotted the results of these equations, they made a swirling pattern just like wings of a butterfly, called as Lorenz attractor, showing that even though the system followed specific rules, it never behaved exactly the same way twice, the very basis of prediction. This showed that long-term weather prediction was impossible as it followed non-linearity. A gentle push to the ball can throw the ball miles away from the predicted path. You can say that this butterfly effect is an orderly chaos, an unpredicted pattern. And this non-linearity is not just with weather. Look at this double pendulum, Lorenz's water model. Even a tiny difference in initial condition will lead to completely different pattern. It's like playing a game whose rules change every time you play. And the same thing is with predicting the flow of traffic. Small changes in traffic, like a single car switching lane or a slight delay at a signal, can lead to large and unpredictable effects down the road. A minor slowdown at one point can ripple through and cause a traffic jam much farther along, even when the road ahead seems clear. If you slightly change the position or speed of few cars, the overall traffic flow can change dramatically over time. And same goes with both economy and stock market. Small changes such as slight shift in consumer behavior, a new policy by government, or even a single influential event can have a large and unpredictable impacts. For example, a small drop in companies' earnings could trigger a massive sell-off, which then spirals into affecting other stocks, investor behaviors, and even broader economic conditions. Now, these systems are sensitive to initial conditions, just like weather and traffic.
You know that 2008 financial market crisis, it also showed chaotic elements. Market predictions failed to account for interactions between the housing market, the banking system, and the global economy, which resulted in global financial meltdown.
The interconnected nature of global economies and stock market means that seemingly minor event in one part of the world could have a cascading effects, leading to unpredictable outcomes or non-linearity. This is why long-term predictions of stock market and economies are incredibly difficult, if not impossible. The more complex and interconnected system, the more likely it is to exhibit chaotic behavior, where small changes lead to big, unexpected results. Economists and financial analysts often use this model to predict trends, but just like weather forecasting or predicting the flow of traffic, these models can only go so far before chaos takes over. So, as much as human wants, some predictions are as good as looking at a crystal ball. Thanks for watching. Hey guys, how did you like this video? Please give it a thumbs up and like, share and subscribe, and I'll see you next time around. Bye bye.